Hi guys, as you heard in class, my voice today is a little bit off, so I apologize. I may re-record this at some point when my voice sounds normal again, but I wanted to make sure you guys had this before you guys took your quiz in case you need to look at it. So what we did today was we looked at how to graph a polynomial. So in order to graph a polynomial, there were two things that we found. We found the end behavior, and we found what our graph does at the zeros. So to start to find the end behavior, we need to know two things. We need to know the degree, and we need to know if the leading coefficient is positive or negative. So the degree, if your equation is in standard form. So remember, standard form looks like either example A or example B. Okay, if it's in that form, you just find the biggest exponent. So for example, for A, that exponent's 5. And then out in front of that 5, it's positive, so it's a positive leading coefficient. So looking at B, that biggest exponent is 4. And right in front of that is a positive. Now, if your equation looks like C or D, that's factored form. In factored form, to find the degree, we have to add up the multiplicities, which, if you remember, are the exponents of those factors. So if I add up the exponents of those factors, I have 2 plus 1 plus 1. So 2 plus 1 plus 1 is 4. Then out in front there, it's a positive leading coefficient because there's no negative out in front. All right, let's try the next one. So my degree, it's in factored form, so add them up. 3 plus 1 plus 5. So that's going to give me a degree of 9. Out in front, there is a negative, so there's a negative leading coefficient. Now, out in front here, if you were to see an x, that would be a factor that we would need to consider when we find the multiplicities, or when we add those up to find the degree. And we'll look at one of those here in a little bit. So what those things to help us determine is what the end behavior looks like. So what we care about is the positive leading coefficient is the leading coefficient positive or negative? If the leading coefficient is positive, our graph is going to end up. So a positive leading coefficient means the right arrow will be going up. If we have a negative leading coefficient, our graph is going to end down. So our arrow is going to go down to the right side. Then we look at the number of the degree. If that number is an odd number, okay, any odd number for a degree, our ends will be opposite. So odd degree has opposite ends. If the degree was an even number, okay, if it's an even number degree, then our ends go in the same direction. So even is same, odd is opposite. Positive leading coefficient means we end up. Negative leading coefficient means we end down. So let's do a little bit of practice on that. So let's find the degree and the leading coefficient. So the degree for this first one is 5, and it's a negative leading coefficient. So I'm going to draw what my ends would look like. Negative leading coefficient ends down. Odd degree is opposite. Then we fill in those statements based on what we just did. So as x approaches negative infinity, that's talking about the left arrow. The left arrow is going up. As x approaches positive infinity, that's talking about the right arrow. The right arrow is going down. All right, let's look at the next one. This one's in factored form. So to find the degree, I need to add up those exponents. So I have 1 on the x, 1 on that factor, and I've got 2 on that factor. So that's a degree of 4. Then I have a positive leading coefficient. There's no negatives out in front. So positive ends up, even degree, same direction. As x approaches negative infinity is the left arrow's up, right arrow's up. All right, let's try our next one. Standard form, biggest exponent. So right here is degree 4, positive leading coefficient. So right side's up, even degree is same. Left arrow, as x approaches negative infinity, is the left arrow up, right arrow up. All right, on this last one, it's factored form, so we'll add them up. There is no x with that 2 in front, so we don't need to add anything. There would have to be an x there otherwise. So there's no x, so I have 1 and 2. So my degree here is 3. Positive leading coefficient. So my right side's up. Degree is odd, so I'm opposite. As x approaches negative infinity is the left arrow. Left arrow is going down. As x approaches positive infinity is the right arrow. Right arrow is going up. So the second thing we have to do when we graph is determine the zeros and what our graph does. So you're going to hear the word zero over the next couple days. Okay, a zero is basically what you did whenever you solved your quadratics by factoring. You took that factor, you set it equal to 0, and you solved. The number that you get is the 0. That 0 is also the x-intercept. So if x minus 3 is a factor, 3 is the 0. The x-intercept is 3, 0. If x plus 5 is the factor, negative 5 is the 0, which means negative 5, 0 is the x-intercept. If 6 is a 0, let's go backwards. If 6 is a 0, x minus 6 is the factor. And 6, 0 is the x-intercept. All right, if negative 10 is the x-intercept, negative 10 is the 0. The way we would write the factor is the opposite sign, x plus 10. Okay, if you feel comfortable, pause it, try these next two. So 1's the 0, x minus 1's the factor. 1, 0 is the intercept. If you see x, or you see 2x, or 3x, or negative x, or negative 5x, okay, all of those would have a 0 of 0. So if you have x and there is no plus or minus, there's no plus or minus after, that's when it's 0. All right, so let's go ahead and actually look at what our graph will do at those points. So all of what your graph looks like at that point is dependent on something called the multiplicity. The multiplicity is just the exponent of the factor. So the multiplicity is the exponent of that factor. Now, depending on what that number is what your graph will do. So if that factor's exponent is 1, your graph will cross at the x-axis. If the multiplicity is even, the graph will bounce. Or you may have heard the word touch or tangent last year, maybe. If the multiplicity is odd and it's greater than 1, then the graph will wiggle or kind of bend at that point. So what that looks like, think about x cubed. Okay, x cubed looks like this. It still grows through that point, but it kind of bends as it goes through. So that's what the wiggle will look like. All right, so what we're going to do to start is we're going to find our x-intercepts. So we're finding the zeros. Okay, so my zeros would be 0, negative 4, and 3. Then let's find the multiplicity. The multiplicity is the exponent of that factor. So the multiplicity for 0 is 1. For x plus 4, it's 1. And for x minus 3, it's 2. Because, again, we're finding the exponent. Then let's determine what our graph actually does at that point because of the multiplicity. So at 0, this graph will cross because the multiplicity is 1. At negative 4, your graph will cross because the multiplicity is 1. At 3, the graph will bounce because the multiplicity is 2. So the 0 is where it's happening, and then that tells us, multiplicity tells us what's happening. All right, let's try the next one. So there is an x here. It's not plus or minus anything, but that means I do have a 0 of 0. X minus 7 would give me a 0 of 7. X plus 6 would give me a 0 of negative 6. Then we look at the multiplicity. Okay, that's the exponent of the factor. So that exponent there is 5. That exponent is 2. That exponent is 1. The multiplicity tells us what our graph will do. Because the multiplicity was 5, at 0, your graph will wiggle. At 7, your graph will bounce. At negative 6, your graph will cross. So let me show you guys what this will actually look like, okay? So this graph has a negative leading coefficient, so we're going to end down. The overall degree here, 5 plus 2 plus 1 is 8, so it's an even number, so my ends will be the same. Let me go ahead and mark my zeros. So 0, 7, and negative 6. So to actually sketch the graph, we'll do that here in a little bit as well, but I want you guys to see one real quick. We need to figure out our ends, which we just did, and what it does at each of those points. So looking at this one, at negative 6, your graph will cross. So I'm going to start at this arrow, and I'm going to move to negative 6 and cross through negative 6. Then the next one I'm going to go near is 0. At 0, my graph will wiggle. So I'm going to go to 0, and it's going to kind of bend or wiggle as I go through it. The last x-intercept is 7. At 7, it tells me I will bounce. So at 7, it's going to bounce off that point and go back in the same direction. And that's my graph. How high or low those points go does not matter. Okay? You can't find that out without using your calculator or without using calculus. So we don't care how high those points go. We just care, are the ends in the right places, and is my graph doing the right thing at the x-axis? All right, if you guys feel comfortable, pause the video, try the next one on your own. All right, so looking at this one, negative 5 does not have any x's. Since it doesn't have any x's, we don't have 0 as a 0. My only zeros are negative 4 and negative 6. Because the multiplicity of that 0 is 3, your graph is going to wiggle. At negative 6, your graph is going to cross. All right, so let's go ahead and actually draw the graphs now. So we're just going to combine those two things together, end behavior and zeros. So let's start with the zeros. My zeros for these factors would be 0, negative 4, and 3. Because 0 is raised to the first power, it will cross at 0. Because negative 4 is raised to the first power, it will cross at negative 4. Because x minus 3 is raised to the second power, my graph will bounce at 3. Then we need to do end behavior. This graph is in factored form, so I'm going to add these up to get the degree. So 2 plus 1 plus 1, my degree is 4. Leading coefficient is positive. So what I'm going to do here, positive means I end up. Even number means I'm in the same direction. So there's my ends. Then let's mark our intercepts. So negative 4, 0, and 3. And then we'll sketch our graph. At negative 4, I'm going to cross. So I'm going to cross through that point. At 0, I'm going to cross. So I'm going to turn and cross through 0. At 3, my graph will bounce. And that's my graph. Again, it doesn't matter how high or low those points are. All right, let's try the next one. Let's find the zeros. Negative 4, negative 6. All right, multiplicity of 3 means it'll wiggle. Multiplicity of 1, it will cross. End behavior. Factored form, add them up. 3 plus 1, degree 4. Negative leading coefficient. So let's mark those zeros, and there's not a lot of space, so it's going to look kind of hard to graph. Sorry, guys. Okay, let's mark our ends. Negative leading coefficient. Even degree. Okay, at negative 6, I will cross. So let's go to negative 6 and cross through. At negative 4, I will wiggle. So it'll just kind of bend. That doesn't need to look perfect. Sometimes people will just do this. Okay, that's all right. I know what you're trying to do at that point. That's okay. It's more important that you can recognize it from a graph for that shape. All right, if you guys feel comfortable, pause the video, try C on your own. All right, so let's get our zeros. 2, 5, negative 1. Exponent is 3, so we wiggle. Exponent is 2, so we cross. Exponent is, Exponent is 2, so we bounce. Exponent is 1, so we cross. Okay? Let's add up our multiplicities to get our end behavior. 3 plus 2 plus 1. So that's 6. Negative leading coefficient. Remember, there's no x there, so that does not affect our degree, but that is our leading coefficient. So even and negative. All right, so then I've got 2, 5, negative 1. Okay, at negative 1, I'm going to cross. I'll scoop this over a little bit. So I'm going to cross through negative 1. At 2, I'm going to wiggle. So it's going to bend and go through. At 5, I'm going to bounce. So D and E, it's going to be the exact same thing. We're just going to factor first. So I'm going to take out my GCF. So my GCF here is x. X comes out. That leaves me with x squared minus 4. Then we have a difference of squares. Difference of squares will factor into x plus 2. X minus 2. So now let's find our zeros. 0, negative 2, 2. Every one of those has an exponent of 1. So every one of those is going to cross. Now you can find end behavior from the original or from the factored. You'll get the same answer either way. If you look at the original, it's the biggest exponent, which is 3. If you add up your multiplicities, you get 3. So either way, we have a positive leading coefficient and a degree of 3. And then I'm going to cross, cross, cross. All right, if you feel comfortable, pause the video, try E. All right, let's take out GCF. In this case, my GCF is x squared. That's the biggest factor that I can take out. So now that's as far as I can factor. My zeros are 0 and 2. 0 has a multiplicity of 2. So at 0, my graph is going to bounce. At 2, my graph is going to cross. We've got an odd degree, a degree of 3. We've got a positive leading coefficient. So there's my ends. At 0, I bounce. At 2, I cross. All right, so F is a little bit trickier for the factoring. So I'm going to start with my GCF. My GCF here is x. Every term has an x. Then I can see what multiplies to 40 and adds to 13. So that's 8 and 5. So now I can find my zeros. 0, negative 8, negative 5. Every one of those is a cross. Positive leading coefficient, odd degree. So up to the right, down to the left. Not a lot of space, sorry. All right, and then we're just going to cross, cross, cross. All right, so the last thing we're going to do is we're just going to work backwards. So we're going to take some information and come up with the equation. So if I have roots, or I have zeros, other words for it, of 3, negative 5, and 1/2. If 3 is a 0 or a root, x minus 3 is the factor. If negative 5 is the root, x plus 5 is the factor. And if 1/2 is the root, x minus 1/2 is the factor. Or you could write that as 2x minus 1. All right, let's look at the next one. It gives me the roots, or the zeros. X minus 7 and x plus 4 will be my factors. But it says I have a degree of 4. Currently, this graph only has a degree of 2. So in order to get a degree of 4, I need to change the multiplicity. I need to change the exponent. So it doesn't matter what I pick as long as they add up to 4. I could do 1 and 3. Or I could do 2 and 2. So there's more than one right answer as long as overall these add up to give you 4. All right, let's look at this last one. 0 of 5 with a multiplicity of 3. So remember what that means. If 5 is a 0, x minus 5 is a factor. Multiplicity is the exponent of that factor. And then a negative leading coefficient out in front. All right, so then this last one again, working backwards. Looking at this graph, we can tell that this is going to have an even degree because my ends are going in the same direction. I can also tell it's a negative leading coefficient because the right end's going down. I can find my zeros. My zeros are the x-intercepts, 2, 3, and 4. And then I can also find the total degree of this function, okay, because it bounces at 2. Because it bounces, that's going to have a multiplicity of 2. Because it wiggles, that's a multiplicity of 3. And because it crosses, that's a multiplicity of 1. If I add those all up, I get a degree of 6, which is an even number. All right, then let's actually write the equation here. So negative leading coefficient. The 0 of 2 is x minus 2 as a factor. Because it bounces, it's squared. Because 3 is a 0, x minus 3 is a factor. It wiggles, so it's to the third power. And then x minus 4 crosses, so it's to the first power. All right, so again, sorry about the voice on this one, guys. I'll maybe try to re-record it when my voice gets back to normal. But hopefully, at least it was helpful to review until then.